Welcome to Cyclohub. In this video, we are discussing the definition of minimum variance unbiased estimator. So first, we are discussing minimum variance unbiased estimator. So by the name of, you can understand that minimum variance. This is a minimum, it has a minimum variance, and this is an unbiased estimator. So there are the 2 points, unbiasedness and the minimum variance. So what it mean by the unbiasedness? If the expected value of the estimator equals the true parameter value. Expected value of any parametric value is always equal to the true parametric value. It is called the unbiasedness. This is a sample statistic, whether it is a true population statistic. Second one is the minimum variance. Among all unbiased estimators, it has the smallest possible variance. It is called the minimum variance unbiased estimators. In other words, MUE is the best unbiased estimator in terms of precision because it has a lower variance. Okay, what are the properties? Because this is unbiasedness, this is the first property. Second is the minimum variance. So of course this is a great property, and which because of this we say it is best. And third one, this is a unique. Why we are saying unique? Unique means that this is only and only one property that is as existing for this estimator. So this is called a unique. If any estimator is MUE, it means that this is a unique property. This is a unique estimator. And the fourth one is the efficiency. So MUE actually achieves the Kramer-Rao lower bound because it has a lower variance. It has a lower variance, so CRLB, Kramer-Rao lower bound, is attainable. Now, how to find MUEs? So there are the several methods to find the MUEs. First method is a Kramer-Rao lower bound. First method is Kramer-Rao lower bound. Accordingly, Kramer-Rao lower bound is given by the variance of theta cap is equal to the and is greater than and equal to 1 upon I theta, where n is also there. So this is the Fisher information. I theta is a Fisher information and n is the sample size. So when sample size increases and variance will decrease. So CRLB provides the minimum possible variance for any unbiased estimator. If an unbiased estimator achieves the CRLB, it is the MBUE. So CRLB is given by this one. Now, what is the Rao-Blackwell theorem? Rao-Blackwell theorem provides to improve an unbiased estimate by conditioning on a sufficient statistic. The definition is here: T is a sufficient statistic for theta, and theta cap is an unbiased estimator. Rao-Blackwell is saying that T is a sufficient statistic. T is a sufficient statistic whether theta cap is an unbiased estimator. Now, there is an estimator when we are expecting that T is already given, which is sufficient, and we are finding the estimator which is unbiased. So it is called the Rao-Blackwell theorem. Is an unbiased estimator with variance less than or equal to the theta cap. Yes. Now, Lehman-Schaff theorem. Third one is Lehman-Schaff theorem. This theorem states that the statistic is complete and sufficient. In this theorem, it should be complete and sufficient than any unbiased estimator based on it is MVUE. Steps is find a sufficient statistic, verify that it is complete, or construct an unbiased estimate based on the T. Actually, these methods are not simple to finding out the parameters, but in some cases we can found, but sometimes it's very difficult to find, so we use less than the other methods. So find a sufficient. First in this one we will find the sufficient statistic, then find the verify the completeness. If the both properties confirm, so it means that this is a Lehman-Chef theorem is verifying. So, and after that we construct the unbiased estimator based on T. Now here are some examples of MUE. Here is one of the example from the normal distribution. Normal distribution is mu sigma square, where sigma square is known. So sample mean is the MUE for the mu. So you can learn about that. What is the MUE for normal distribution? In most of the cases, we can say mu is the MUE for normal distribution. One more is sigma square, but it is not a MUE, right? The second one, because it is unbiased and achieves the CRLB, right? Because this is the mu and biased, and the variance of mu cap is equal to sigma square upon n. So n is increases, variance will be less. And the second example is variance of normal distribution. Variance of normal distribution look like this one, and variance um, of sigma square is the adjusted sample variance. So sigma square is also a MUE, and it is unbiased and it achieves the CRLB if mu is unknown, and the MUE for sigma square is the adjusted sample variance. So actually sigma square is also a MUE. It was my mistake that I have given that sigma square is not, but it is actually a MUE also. Important terms are here. Suppose what is unbiased, estimate sufficient, complete, fissure. And we know unbiased, sufficient. But what is mean by the complete statistics? A statistics for which no non-zero function of it has zero expectations. It is called a complete statistic. A Fisher information, a measure of the amount of information that the sample provides about the parameter. It is called the Fisher information. And Cramer law or lower bound, this is called a possible variance, minimum possible variance for any unbiased estimators. Here are some advantages of MVUE, and limitations are also given here. Thank you so much for watching. If you have other queries related to any other estimators, so we are here for help you. Thank you so much for watching.